So to wrap up the main portion of our agenda today, I would like to invite Kyriaki Kalimeri and Marc van der Homburg to the stage. Kyriaki is a researcher at the ISI Foundation and a senior research consultant at UNICEF, and holds a Ph.D. degree from the University of Trento since 2013. She was a visiting scholar at the Human Dynamics Group at the MIT Media Lab. Her current research interests lie at the intersection of computational social science, engineering, and particularly in employing statistical machine learning and natural language processing for humanitarian response. Marc is the scientific lead at 510, an initiative of the Netherlands Red Cross, and a professor on the Princess Margaret Chair, Data for Disaster Resilience at the Faculty of Geoinformation Science and Earth Observation of the University of Twente. Marc is shaping the growth of 510, an initiative of the Netherlands Red Cross from its 2016 inception. He developed and implemented an applied research agenda tailored to the needs of the Red Crescent movement, while establishing close collaborations with universities and knowledge institutes. At the Faculty of Geoinformation Science and Earth Observation of the University of Twente, he focuses on enhancing the quality of risk and impact data, trigger models for anticipatory action, and building evidence for nature-based solutions. In their keynote, Kyriaki and Marc will talk about how 510, an initiative of the Netherlands Red Cross, and the ISI Foundation, and the OCHA Centre for Humanitarian Data have joined forces to leverage big data science for anticipatory action and humanitarian responses. Their talk will focus on the latest efforts to improve and expand the model developed by 510, predicting housing damage caused by tropical cyclones in the Philippines, and the transferability of the model to Fiji, Haiti, and Vietnam. Thank you.
Thank you for inviting me. And yeah, also it's a pleasure to be here. The long-standing collaboration with Analytics for a Better World that started about, I could say maybe even before ABW was there, about 10 years ago. Robert and I were in dusty rural Bangladesh doing research on the data gaps there. And now we're standing here. And also, yeah, with ABW and Ortec, we work together in, for example, coming up with a digital transformation strategy for Red Cross national societies. And then also the fellow program. So many ways we work together, also with text mining research. But now we will focus on one of the aspects we are working on. And before I dive into that, I want to very briefly introduce 510, because not maybe every one of you knows who we are. So we aim to improve the speed and the quality of humanitarian aid by creating products and services using data and digital. We are, well, 510 million square kilometers is the total surface of the Earth. And we aim to support Red Cross national societies in many different countries. I think up till now we have been able to help around 45 Red Cross national societies. In total, there are 192. This was already explained before. So we were founded in 2016 when I left the TNO and I joined the Red Cross. And we have now more than 40 people staff, and we work also a lot with students and volunteers and professionals that help us with their data science skills. We work on 5 thematic areas. And of course, given that I have only around about 15 minutes, I cannot discuss everything. But yeah, we work on anticipatory action, cash and voucher assistance, community engagement and accountability, emergency support, and water and landscape. And you can actually plot these thematic areas that we work on also on a so-called disaster risk management cycle. I'm not sure how many of you use that concept. Let's say it's a bit simplified, but it's basically telling you what can you do before a disaster happens and after a disaster happens. So yeah, you can see we work on preparedness, which is before the disaster happens. We work on response and a little bit on mitigation. So we'll focus now on kind of this preparedness response part of what we are working on. Commonly, let's say, or at least for sure 10 years ago, all the humanitarian funding was going to response. And we had to kind of wait till the disaster happened, and then funding was available. But there has been a paradigm shift over the last 5 years, where more and more donors are willing to release funding also in a short time period before a disaster happens. We call this anticipatory action, or early warning, early action. It also links to the early warning for all initiative from the UN. And for that, we really need predictive analytics, because we need to be able to predict, for example, 3 days before a tropical cyclone makes landfall, we need to be able to predict what will be the humanitarian impact. And this actually you can do for many hazards. So I will now, in my talk, mainly focus on tropical cyclones, but we are doing this also for hazards like droughts, river floods, cold waves, volcanic ashfall, or even for epidemics like malaria or cholera, as was presented before also by MSF. So also there we see this movement for anticipatory action. So as I said, I will focus on tropical cyclones. And I wanted to start a bit from kind of, let's say, the end user point of view before I dive into the data science aspect. So we have a mechanism in the Red Cross, but also many other humanitarian organizations have this, is that there need to be a protocol in place so that it's all going automatically. Of course, a few days before a disaster happens, you have no time to start negotiating or discussing. So we have this early action protocol that, for example, was approved for the Philippines in 2019 and in Bangladesh in 2018, that really describes exactly which actions are going to be taken and which trigger is going to be used. And this trigger, there are a few criteria for it. For example, we have to provide data that shows that the impact of the forecasted event will be really considerable. There has to be considerable humanitarian impact, because we cannot trigger, let's say, every year. There's simply no funding for that, and we need to make sure that we trigger for these extreme events. We also need a clear methodology to tell the Red Cross where to act, based on a combination of vulnerability, the poverty, for example, of people, their exposure, and then also, of course, the weather forecast. We also need calculations to know what is the probability of what we call acting in vain. It will sometimes go wrong, that we will ask people to evacuate, or we will support them, but then the weather forecast is wrong, and we will end up acting in vain. So we need to know also, for example, the false alarm ratio of these trigger models. So yeah, if we need to know this, we can, of course, try to make use of all this data that is available. We have the big data, remote sensing was already mentioned before by Space for Good. We have also maybe call detail records from mobile phone operators. And we have also what you could call small data, so the household survey data, for example, that becomes nowadays also more and more unlocked via geospatial data repositories. So then the question is, are we going to use advanced data science and AI, or can we also just make more simple expert-based models or rule-based models? And I want to kind of focus in my talk now on an example for tropical cyclone impact-based forecasting modeling to show how we could maybe make that choice between a more simple model or a more advanced model. But this is actually then for every hazard that we have to do this and to think about this. Because there are a lot of possibilities to use AI, of course. So this is an example from one of a paper from 2020. And at that time, apparently, generative AI was not yet that widespread, because it is not mentioned here, but for sure it should be there as well. But here you can see examples of supervised learning, unsupervised learning, deep learning. And you can use that in all these different disaster management cycle phases. We have also worked, for example, with Pipple, another partner of ABW, on, for example, the deep learning for damage assessments. If we're then going to develop this trigger model for anticipatory action, we usually go through a number of steps. So, for example, we try, first of all, to understand the risk in the area. So we expand our risk database. Then we also need to make an inventory of the weather models, the different weather forecasts. And we need historical data on the impact of historical events. And there we also actually worked with text mining, for example. And then in step 4, we bring this all together, and then we can start modeling. And there we can make this choice, whether we make a simple model or a more complex model. So what do I mean with, let's say, the complexity of the model? Well, I guess first of all, you could talk about an expert model or using local or indigenous knowledge, where you kind of maybe rely on that separately, or you can use this knowledge to inform your more scientific models. And then we have these more elementary models that are often based on mathematical equations or physics kind of type of models, where we model the impact. So for example, you can use a damage curve that tells you if you have a certain wind speed, what will then be the damage to the house. And the third one is the statistical model or the data-driven model, where we use patterns into, let's say, the predictors and the predictants. And actually, in 2 days, I'm happy that Sahara Sedine will be coming over from Nepal, and she will start her Ph.D. research into these different trigger models for different hazards. So to start with the really simple model, so it's even maybe before an elementary model, that would be just overlaying different, let's say, indicators on top of one another. So what you see here is, for example, we could say, okay, where is the Red Cross deployed? We plot that on a GIS map. We then add the forecast of the wind speed of the tropical cyclone. We add the layer of poverty and where are the houses that are vulnerable. And then we kind of combine them, and then we have an intervention map. The most simple approach. One step more complicated is then this elementary impact model. So here we use this, let's say, damage curve that gives us a relationship between the wind speed and the damage to a house. And we usually need maybe only one historical event to kind of come up with such a damage curve, or to have some information. And then we can build such an elementary model. An example of this is what they did in Bangladesh. So they used this model, and they had the trigger mechanism as follows. So when a wind speed of 125 kilometers per hour is reached, and the landfall in an area with 25% or more houses completely damaged, then we will take action. Then a more, well, let's say, complicated model is this statistical impact model, where we have around 40 predictors. And later on, I will, or Kyriaki will explain how we can also reduce the number of predictors. But here we had around 40 predictors, and we trained it on around 60 historical events. And we used the XGBoost or linear regression model to train this. And this is used actually currently in the Philippines. And the trigger is when the model predicts that 10% or more of the houses will be completely damaged in at least 3 municipalities, 3 days before. And we need these 3 days because you need also time to implement the early actions. So we cannot wait a bit more and reduce the uncertainty, because then we have not enough time. So which model then to use? And I think in the panel discussion, explainable AI came up already a little bit. And yeah, we are also, not surprisingly, looking into the direction of explainable AI to help us in making then this selection between these different types of models. And what you can see here is a bit like how can you go from a bit more simple models, classification models, regression models on the left-hand side, to a more complicated models, let's say reinforcement learning or semi-supervised learning. And then with explainable AI, you can evaluate these models, what they call ante hoc or post hoc. So you can basically look under the hood, intrinsically, try to understand how these models work. Or as Marc, I think, was saying in the panel discussion, well, we don't care how the model works intrinsically. We just look at the performance post hoc. And then there are also hybrid modes to do this. So yeah, that's one way we thought about going forward. So that's actually then work that Sahara Sedine did during her master thesis at the University of Trento. So she looked at this intrinsic and this post hoc way of analyzing different models. And she also then made a nice, let's say, dashboard that the users could use. So this group of people in country that have to decide on these models, because actually we can, as 510, propose to use the elementary model or the statistical model. But in the end, of course, the actors in country, they have to decide which model they trust and which model they want to use. So we made this dashboard where you can then see, for example, the forecast of the event, where it will make landfall, the wind speed. You can then also see in this model, at least for a historical event, what will be the actual damage and what will the model predict. You can then also make a choice of your modeling technique, so the elementary of the statistical model. You can then see what will be the prediction accuracy. And you can also play around a bit with some of the settings that you can select yourself. For example, you can play around with the trigger threshold. So in the end, you have to make a choice, of course. So in the Philippines, the choice was made for this statistical model. And what you can see here is what the Philippine Red Cross receives every 6 hours once a typhoon comes into the Philippines area of responsibility. What you will see now is that, and that is that line that you see here, that there's still quite a shift. And that's because the weather forecast is not so good yet. So our machine learning model can do nothing about it. So in this first period, the forecast scale, it's called, or the weather uncertainty, plays a large role in whether this model will do what it is supposed to do. So here you can see that in more detail. On the left-hand side, you see a plot of the time on the horizontal axis, so 72 hours before. You can see that, for example, the track of the typhoon can be 300 or 400 kilometers off. It depends a bit. There are 9 different providers of this weather information for which we did this analysis. So some are maybe a bit better than others. But we do this analysis then to try to see if we can pick the best one. On the right-hand side, you can see then the performance of the machine learning model. And maybe some of you are familiar with these kind of approaches like false positives and false negatives. And also here you can sometimes make a choice, of course, whether you want to make the model better for false positives or better for false negatives. So if you have more false positives, then the model will wrongly predict the damage, and then you will be acting in vain. If you have more false negatives, the model will miss certain events. So that's maybe also not something that you want. So there you can then play around a little bit and fine-tune the model. The other thing we can play around with is whether we have a one-stage model or a two-stage model. So on the left-hand side, you see a model that just predicting yes or no, this municipality will be damaged, but you have not much more information. On the right-hand side, you see what comes out of a regression model, where you have more quantitative information. And this is actually, then a cliffhanger or a spoiler alert. Kyriaki will tell more about how we then made a decision on this. Similarly, for the aggregation level, what you can see here is that the model is working on this, what we call municipality level in the Philippines. So it's a kind of a sub-district level. So that means that we have to make use of another approach to identify the households that we want to help. So the model is only telling us this municipality will be hit. And then there is a human in the loop part of the process where so-called barangay committees, so local groups of actors, they tell us which households to help. But of course, it is, I think, a bit better if the model would be less rough, let's say. So we then decided to use building delineation data to disaggregate and to go to a lower level. And that's again in collaboration with Kyriaki. So she will tell more about how we are doing this. So that brings me then to the last part of my talk, which is about accountability. And I think this was also the panel discussion. Nice that this came to the how to say it, to the foreground. Like, is it the legal issue or is it the ethical issue? But yeah, also with our machine learning model, what if this trigger is missing out on people? Or what if organizations in the Philippines are all using different trigger models? And this is happening already, actually. So, for example, for drought, recently Oxfam triggered for the southern part of the Philippines, whereas FAO triggered for the northern part of the country. And the government was really confused. They didn't understand why. They were triggering for the same drought, they thought. So yeah, then we have to bring in maybe public accountability concepts. So, for example, you have algorithmic accountability. Like, who is the actor? Is that the organization who initiates the early actions or the response, or the Philippine Red Cross? Or is it the ISI Foundation, or is it 510? Because we made the algorithm. And who's then the forum that's going to judge this actor? Are the people on the ground going to complain and say, hey, why did I not receive early action support? Or will maybe the donor start pointing fingers? Or kind of a scientific or validation committee that we have, for example, in the Red Cross. And what are then the consequences? Well, this is all kind of in an early phase. So these processes are not really clear yet. But I think it will be important to make this clear in the coming years. And what we can do, at least from our side, I think, is to be able to audit our, let's say, modeling approaches. So here you can see an example of research we also did with ITC on auditing what we call a geointelligence workflow. So all the steps that you are taking in your let's say, data cycle, you can identify or try to identify the biases, for example. And there are different forms of biases. And it goes maybe too deep now to explain all of them, but one of the biases, for example, can be in this building delineation algorithm, if we use that. So that's, and another bias is, for example, the representation bias. If you have cloud cover and certain images, part of your image, your remote sensing image, you cannot use, you will already have automatically a bias, of course. But specifically then for this building delineation algorithm, we also decided to look into that into more depth with Caroline Gevaert. And this image is, I think, very nicely depicting the issue. So on the right-hand side, you see, let's say, the yellow algorithm. That's very nicely identifying the residential areas or buildings, the big buildings. But in the middle, the slum area, you see that it has quite some difficulties in identifying the buildings there. And the algorithm in white is doing a much better job. Of course, we, as the Red Cross, we want to have that algorithm on the left. So what we did actually is we compared Google and Microsoft open building delineation data sets. And we also used an OpenStreetMap. And we compared these three to see which one is performing better. And we also use sensitive attributes, like, for example, if it's a poor or a rich area, to see if these algorithms are maybe performing better in a rich area than in a poor area. And we use different metrics to do this. So if you want to know more about this, then yeah, this publication will hopefully soon be out. I can already maybe say that it's not a very clear black and white answer. That's for sure. It can depend on the area, and it's something you have to look into contagiously, I think. So to conclude, a few key takeaways from my side. I think it's important to carefully assess when and where in the disaster management cycle we can apply AI and big data, and complex is not always better. And AI solutions will always be part of a larger socio-technical system. So we have to watch out for a kind of a framing trap that we are thinking, narrowing it down only to this AI part. So we have to consider the human in the loop part. And we can use explainable AI principles to assess these different trigger models. And important to assess for biases and fairness, because I think only then we can make sure that we are accountable to the people that we, as the Red Cross, want to support. And I guess with that, I hand over to Kyriaki. Yeah.
Okay. You will hate me and move all the time, okay? Okay. Hello, thank you so much for the invitation. As Kate said, I'm working for ISI Foundation and UNICEF, and I am an electronic engineer. I am a classical machine learning person. That over the years, I started to move more and more into human behavior understanding and how we can use our machine learning models and all the data that we have outside to understand how people make decisions, how we can contribute to controversial social issues and polarization in society. Then I moved into a more algorithmic biases and both data and algorithmic biases issues. And then I ended up in working more and more for humanitarian response. So the institute I'm going to present to you is ISI Foundation. It's a very small research institute with 40 years of history. And it started as a quantum organization, quantum research center. And then they moved a lot towards computational epidemiology. And more recently, we are doing more and more research on social impact. We are purely academics. So our background is physics or computer science, but we are all purely academics. And our main question is, okay, how we can use what we know how to do to help people, to help society. And we have created this network of problem owners, data owners, and we bring in the research, the science, trying to understand how much we can contribute and where we can contribute. So basically what happens is that these organizations, they come to us with a very with a question that is important to them, and we try to see how we can put things together to address this question. Perhaps sometimes we can, sometimes we can't, but this is a little bit the way that we are working. Part of this infrastructure is the collaboration that we have with Marc and in 510 and OCHA. And basically what we did here, I know that Marc wants me to explain the bundle, but what I'm going to explain is a little bit the idea behind it so that you understand our work. So what happened is that 510 had already implemented a model that was used in the Philippines. And what we came in to do is that we did very, very simple things like feature selection, or we tried different machine learning algorithms, but really off-the-shelf stuff, nothing fancy, nothing too extreme. But we managed to improve their model. And we also proposed a little bit more fine-grained spatial approach, like instead of using the admin level 2, we passed in the grid level, and we use a little bit features that you can find globally online, with the idea of moving to models that are not country dependent so much. So adding a little bit more insights in the model, we managed to improve it quite a bit. And it's here, I don't know how much you see what is happening, but here you have the actual damage. This is the model that 510 had in production when we started collaborating. And this is our model. So numbers are not so important, the little one, but what is important is that this model would predict 25 municipalities as affected, while we were able to predict 35. I mean, it's an improvement. It's not perfect, but it is an improvement, and we are very happy because it's implemented now in the Philippines early anticipatory action, and it's also part of the state of humanitarian data report. So we are moving to make this model global. And how we're doing this, we're replacing all the features that we're using with open and globally available features. And there, of course, you don't have the luxury of having countries that are data rich and like Philippines, that you can have all the information that you want about the households, but you have less, perhaps not of the quality that you would like to, but the idea is to have something that works for all countries and not just for one case study, and then it's not usable anymore. We also started considering things like vulnerability. So what happens in the richer or the poorer or the urban or the rural parts of the country. And of course, I'm going to use this talk as a psychological therapy for me to talk to you about my problems in so this is one of my biggest problems. So again, as a machine learning person, you live in a universe in which you have your ground truth data, you have your model, you fine tune your optimization functions, you predict your data, you're happy. No, you report an accuracy and you're happy. Here, ground truth data that perhaps come from a government, they're weird, right? I mean, I have a typhoon that is passing here and I have ground truth data that are thousands of kilometers away. So yes, typhoons are big, but there is something going on, right? So what do I do? And I mean, we are trying, but every country has its own particularities. So when things are, let's say, not too complex, it does work, and we are able to go from to do also to transfer the model from one country to another. So these are models that have been trained in the Philippines and tested on Fiji, and we do cross-validation, and it works quite well when more or less the data are in place. So still we have things to solve, like for example, you see what is the actual damage reported, what is that we are predicting, and the difference where we are over predicting and where we are under predicting. So of course, we haven't solved the problem yet. This is an ongoing work, but we are moving towards something that is not country dependent and not close to data universe of a specific country. So going back to how we work in ISI, I'm going to flash a few projects that it's mostly for to trigger your interest if you have ideas and if you want to collaborate with us, so that you know that we do different kinds of things. So this is a little bit on me. So I'm I'm egoistically promoting my own interests here. So for example, one project that we did in collaboration with UNICEF was in Indonesia. What happened in Indonesia? So UNICEF came with a very clean question to us, and that was, okay, Indonesia has different surveys and they have this program that is a social benefits program. So they are basically giving money and monetary benefits to the poorer slices of the population. What happens if instead of waiting for the official data that are slow and costly and how are official data, what would happen if we just take the relative wealth index of Facebook and just use that one? So, when relative wealth index says that this place is poor, we allocate money there. And we said, okay, this is a very cool idea. Let's try how it works. And there again, we faced a series of issues. For example, even between the national official surveys, there are differences. There are methodological differences of how things are put together, how each questionnaire is assembled together. What is so already in the starting point, we had a lot of uncertainty of what is happening, but I will stop with my psychological support here. What happened is that when we took Facebook's relative wealth index into play and we started to predict with that, it worked pretty well. We had like 80% of correctly predicted population, like who is poor and who is rich and where should the benefit go. And then what we discovered is that, yes, okay, it works pretty well. But when you go down into the slices of the population that you're looking at, what happens is that it works pretty well for the rich part of the country, but in the 14th quantile of the poorest population, the actual population where you want the money to go, basically we had 50% of wrongly classified people. And these are interesting things to see if you're starting with your computer science background and you say, okay, accuracy of 0.8, I'm good, we're closing, next problem, right? But when people come into play, you have to be very cautious of what you are doing. And even if numbers are really nice and they tell the story you want to say, you still have to go inside and see what is happening. Another project that we did, this is more on the NLP side, is in collaboration with Data Friendly Space, with his non-for-profit organization. And they also came with a very simple question. So Data Friendly Space is developing NLP software for UN organizations, and they are helping, basically they're doing NLP for humanitarian documents. And we collaborate since a few years, and they came with this very simple question, and they said, okay, I have documents that are produced during emergencies. The way that, I mean, those documents are written by people in the field, so, you know, of course, they are not academic documents, well structured. They are documents that are just delivering information where it's needed. Perhaps the structure is not perfect, perhaps there are mistakes, but, you know, they are important to, and their question is, okay, we have all this huge quantity of documents, and we need a way to be able to do information retrieval of spaces, of places, of locations. So where did the earthquake happen? Or I don't know, in that place, what kinds of disasters did they have? So we said, okay, very simple information retrieval process. We take the documents, we do a spacey, we use John names to retrieve the names, and we're good, right? And when we did that, we got the blue points. And then we looked at the map. Very important to look at the map. And then we say, okay, I don't think it's reasonable that most of the humanitarian aid is in the US and Europe, right? I mean, there is something that is weird here. So I started screaming to the student. I say, I mean, you have done something wrong. Go and check your model, because, you know, it cannot be that I live in the most dangerous place of the globe. And basically what we figured out is that it was not the student that was wrong, but is the fact that we are based on proprietary software, on software that was built for commercial purposes. So GeoNames was not built for humanitarian action. GeoNames was built for mapping, I don't know, restaurants. The real demand of these tools, and not just the specific library, but in general, the real demand and the real purpose they were built to address are problems of, you know, restaurants, hotels, where to go, Google Maps, and stuff like this. So they are already always biasing when there is a let's say ambiguity of where the place is. So I don't know, Tripoli in Greece or Tripoli in Africa, or perhaps a Tripoli in the US, they will automatically assign it to the US or to Europe, but they will never assign it where the real problem is. So we went inside the documents, we did a little bit of annotation, and then we retrained our Roberta model to try and predict the actual place of the emergency. And this is where we got, for the same documents, the red dots. So, you know, there is quite a bit of a spread out in what is happening. So these are a few examples of what we're doing. And the other problem that we have, because I kind of come back to existentialist problems I have, the other problems that we have are the actual mathematical modeling and the actual metrics that we use. So here, this is the wildfires in Chile that happened in January, sorry. And And here we have an amazing collaboration with Telefónica in Chile. And we have data that are longitudinal. We know not just what is happening now, but what has been happening since ever. We can track the same person along since 2017. We have really amazing access to amazing data because of our collaborator, Leo Ferres. And what we said is that, okay, we have this amazing data source. Let's see what happens during the wildfire. Where do the people go? Do they evacuate? Do they go all at the same place? Or I don't know, is there a better way to do the evacuation modeling? Or even more simple questions like, what are the socio-demographic inequalities? Like, I don't know, do the rich have more flexibility in leaving the place and never coming back, while perhaps a poorer person remains there? And these are all questions that in our traditional mobility projects are things that you can do very simply, because you know where the person is. You can do home location detection. There are a bunch of standard algorithms that you can use for this. And you can say, okay, I mean, I know that this person lives here because over the last 7 weeks, he has been living at the same place. So, I assign him to that socio-demographic group. Also because Chile is very segregated, so there are very neat socio-demographic divisions on the map. But what happens is that in an emergency, first, you have to do things fast. Second, this is a touristic location. I have people that are there just because it was summer for them and they just visited the place. So I cannot do home location prediction. And even if I have access to 7 weeks before, it doesn't mean that these people live there, but still they are part of the humanitarian response that has, not humanitarian, but the response that has to be has to take place. And then, even if I send SMS, for example, we have many towers that are burned and they don't send the message they are supposed to send. So, or for example, I don't know, a very standard thing that we do when we do mobility modeling is that data points that are very sparse, you usually exclude them, but perhaps these are the people that you want to address, because these are the remote populations in the middle of the fire that are in need of communication. They should receive the message that they should evacuate or something like that. So these are a little bit a set of things that are changing when you're passing from typical problems in data science that are, they are benchmarked and you know how to address them, and there are standard algorithms that work or don't work, to other similar but still different applications like the humanitarian sector, where basically you're working with the outliers of your models, or you're working with you make algorithmic choices that you cannot afford to do because you're losing the people that you're interested in. That said, there are a lot of potentials. So even, for example, a very simple mapping of where the people, how much the people moved, showed that when the SMS to evacuate was sent, people had already left the place. So, even with very, very simple, they had left the place like half an hour earlier. So even with very simple analytics, sometimes you don't have to be very complicated, and you don't have to be very fancy in the terms of the algorithms or the approaches that you use, but sometimes even very simple counts of people that are moving can give you a very immediate picture of what is happening. And if you say to the right person, they have the time to react or the insights to know where to look. Thank you so much. I can. I know I speak fast and write to me if you have things that you didn't understand. Any questions?
Yeah, we have time for maybe one or two questions. There's one online. Nope, you can't say it tonight.
So online, is there a way to enforce principles like those of Red Cross with AI?
Are there ways to enforce principles of Red Cross with AI? Like those of Red Cross with AI? I think
What
that
do you
maybe is
mean?
for Mark.
What do you mean? Yeah.
Just
Well, actually, my colleague Jacobo is now undertaking research with a master thesis student where, at least for generative AI, we are looking into prompt engineering and to see how AI reacts and if it complies with the neutrality and impartiality principles of the Red Cross. So that's for generative AI. But yeah, to enforce it, it also depends very much on the data that we have. So like the representation bias I was talking about, if the data is really not good, then it's sometimes very hard. We try to work with proxies then, but if there is already a bias in the data, then it's hard to enforce something.
Perfect. Are there any other questions? Yes.
About the vulnerability indices,
Hmm.
you said we still need one for the global impact model. Then you take one, the relative wealth index, and is the tail of the distribution of the big bananas. So, is there any good one, or is it you don't need to raise the type of model? You don't need to be sensitive to the state. Would you recommend people that never studied this?
So the relative wealth index is interesting, but it's not for all the countries, and it has this particularity. So we are using the international wealth index that I showed before, but I don't know if there is anything better than this globally available. The other issue with the indicators is that they are usually at the country level, so
yeah,
the resolution of it.
Yeah, I think that is maybe also showing a bit the limitations of a global model. In the end, I think what is also a bit the idea of OCHA is that with the global model, we can raise interest in a country for developing an impact-based forecasting model. But in the end, I think it is best if the government actors themselves are going to tailor the model to their specific context and use then also local data sets. But this is a good way to start and to quickly make a model for a new country. But in the end, I think a local model should always be possible that it outperforms the global model.
We're gonna stop here. Thank you so much, guys. And if you can find them during the networking drinks if you have more questions.